Today we are going to be talking about graphing linear equations in slope-intercept form. So our learning goal I will find slopes and y-intercepts of graphs of linear equations. Also, I will graph linear equations written in slope-intercept form. So in order to do this, we need to remember a couple of things. We need to remember, first of all, what the intercepts are. So to start off with, if we have a graph and we talk about the y-intercept, the y-intercept is the point where the graph crosses the y-axis, or where it intercepts the y-axis. So, for example, look, I have a ruler today. If we draw a quick little graph here, and I put a line on this graph, here's my line. The y-intercept is this point right here. So in this case, the coordinates of my, actually I should make that red. The coordinates of my y-intercept are 0, 3. And our y-intercept is always going to have a 0 for the x-coordinate because it's on the y-axis. You're not moving side to side at all. So the y-intercept, we could say it's of the form 0, and then we use the letter b. I don't know why we use b. We just use b. And then one other way to think about that is this is where x equals 0. So the y-intercept is when our x is 0. We also can talk about the x-intercept. So this would be our x-intercept. It's the same thing, except for it's the point where the graph crosses the x-axis. So in this case, I go over 2 and I don't go up or down at all. So my point is 2, 0. That's our x-intercept. And if you think about it, for our x-intercept, our y value is always going to be 0. So that's always going to be something like, and we can use any letter we want here. This doesn't really have a letter. Like A0. And this is also, it's going to be where y equals 0. So if you're given an equation and you want to find the x-intercept, you put in 0 for y. If you have an equation you want to find the y-intercept, you put in 0 for x. Turns out we actually have a faster way to do that too. Because when we have slope-intercept form, you'll remember this from last year, y equals mx plus b. This is slope-intercept form. We love slope-intercept form, despite what you may be thinking right now, because it tells us two super important
teachers.
Okay, sorry about that. There's probably just a weird cutout. An announcement came on the PA. You didn't need to hear it. So slope-intercept form we love because it gives us two very, very, very important pieces of information. You'll see a b here. It's not a coincidence that this is 0b. So this number, this constant that we're going to have at the end of slope-intercept form, that is the y-coordinate of our y-intercept, which is why it's called slope-intercept form. And then this number right here, the number or the coefficient for the x, that's always going to be our slope. So it's really nice. Oh, slope-intercept form. It's really nice if that's written as a fraction, because then that just tells us how much to count up and over or down and over or whatever. So slope-intercept form is what we're going to be using to graph today. So first thing that you need to be able to do is to just identify the slope and the intercept when you're given an equation. So for example, if you have this equation, this will be example 1. When you have this equation right here, by just looking at it, you can tell exactly what the slope of this line is, and you can see where it crosses the y-axis. Technically, for it to be in slope-intercept form, you might think about it like this, as plus a negative 5, but you should be able to recognize that pretty quickly. That subtracting 5, in your head, it's the same as adding a negative 5. So what that's telling you is the slope of this line is 3/4, which means you're going to go, from point to point, you go up 3/4, and your y-intercept is negative 5, or the coordinates would be 0, negative 5. So if I wanted to graph this, I would draw a quick coordinate plane, and then pretty quickly I can graph this without having to make a table. I know that I'm starting at my y-intercept, or that's a good starting point, at 0, negative 5. So 0, 1, 2, 3, 4, 5 down is negative 5. And then to connect my next point, or to make my next point, my slope is 3/4. So from this point, I go up 1, 2, 3, and I go over 1, 2, 3, 4. There's another point on my line. Now I have 2 points. I can connect them. And this right here is the line y equals 3/4 x minus 5. So using slope-intercept form, I can make a graph really fast, and I don't have to make a table like you did for the first section where you had to make a table and pick a whole bunch of points and do all that stuff. Now we can check our line and see if it makes sense or not. This point right here that I found, the coordinates are 1, 2, 3, 4, negative 2. So what I can do to see if this really works, or if this is really the correct line, I can plug 4 in for x and negative 2 in for y and see if that works out. So I would do negative 2 equals 3/4 times 4 minus 5. So I substituted those coordinates into my original equation up here. 3/4 times 4, oh, that makes it easy. That's just 3 minus 5. And then I get negative 2 equals negative 2. That's definitely true, so that point worked. It's a pretty good indicator that my line matches up with my graph. So I know you guys hated slope-intercept form, but hopefully you're beginning to see that it makes life so much easier. Every once in a while, or actually more often than that, you'll be given an equation that is not in slope-intercept form yet. So if I had something like this, y plus 1/2 equals negative 6x. This is technically not in slope-intercept form because remember, for slope-intercept form, it's y equals mx plus b. Y doesn't have anybody with him. He's totally by himself. So in order to fix this, or put it in slope-intercept form, I need to solve for y, which shouldn't be too tricky. Right now I'm adding a half to y, so I'm going to subtract 1/2 from y. If I subtract 1/2 from y, I have to subtract 1/2 from the other side of the equation, and I'll get y equals negative 6x minus 1/2. And let's look, the slope, or remember we can call that m, is negative 6, or negative 6 over 1, if you're thinking about it as a fraction, so down 6 over 1. My y-intercept, b, is negative 1/2, or the point 0, negative 1/2. And so I would start off by graphing that negative 1/2 from that point, go down 6 over 1, down 6 over 1, and I would be good to go with that graph. So what I would like you to do for your first on your own chunk, I want you to just tell me the slope and y-intercept of these two. Y equals 3x minus 7. So tell me what the slope is, what the y-intercept is. And for number 2, y minus 1 equals negative 2/3 x. So again, tell me the slope, tell me the y-intercept for that. You don't need to actually graph them. Okay, your first problem was 3x minus 7. The slope here is the number in front of the x, so your slope, I'm going to call that m, that's 3. Your y-intercept, or b, is negative 7. Another way of writing that would be 0, negative 7. So both of those would be acceptable. So that was the on your own number 1. Number 2, you started with y minus 1 equals negative 2/3 x. So in order to solve for y, that's y minus 1, so I need to add 1 to each side. So y equals negative 2/3 x plus 1. My slope is negative 2/3. That means I'm going to go down 2 over 3. My y-intercept is 1, or the point 0, 1. So that wasn't too terrible. And that's about it. So I showed you how to graph it. I showed you how to just identify the slope and the y-intercept. One other thing that you might need to know is how to find the x-intercept. So let me just do an example. I don't know. If I had y equals 2x minus 4 and I wanted to find the x-intercept, remember the x-intercept is where this graph is going to cross the x-axis. So what I would do to find that, the x-axis has a y-coordinate of 0. So all I do is plug in 0 for y and I solve for x. So to do that, I add 4 to each side. So 4 equals 2x, divide each side by 2, and I get x equals 2. So that tells me my x-intercept is at 2, 0. So if I were to graph this, let's see, 1, 2, 3, 4, up 2 over 1, up 2 over 1, I can see that my graph is crossing the x-axis at 2, 0, which is exactly where I found it would cross the x-axis. So that's just a good thing to know, is how to find the x-intercept as well. And that's about it. So good luck with the homework.